Hi, a warm welcome to you. In this video, we will try to understand about the concept of similarity in triangles. Before moving ahead with similarity in triangles, let us try to understand similarity in general terms. Let's take a simple example, which is real life example. My kid wants Ferrari 458 Italia. No, not the original one. He wants a toy. You can see here two pictures. I have taken the picture of the Ferrari 458 Italia, and this is the picture of the image of the toy. If I look at the box of this toy, I see somewhere in one corner which says that scale equal to 1:12. The meaning of that, what is the meaning of that? The meaning is that if I take this particular toy and enlarge it by 12 times, then it becomes of the same size of that of the Ferrari 458 Italia running car. That means the shape is same but the size are different, then they are called as similar. Now come to the triangles. In triangles also the same rule applies, that not only in triangle, any polygon for that matter. So in triangles we know that the shape is given by the angle made by the sides. That means the angles of both the triangles should be same. That means this angle, corresponding angle, should be same. Similarly, this corresponding angle should be the same, and also this angle should be the same. So now we had made sure that if the angles are same, then the shape is same, but the size should be in proportion. That means the sides should be in proportion. That means the ratio of the sides in both the triangles, corresponding sides, should be same. That means the sides ratio should be same. Then they are called as similar triangles. That means if I take, suppose, let us say that this is equal to 8, this is equal to 8, and this is equal to 6. This is of 3, 4, 4, and let us name this, say that this is A, B, and C, this is D, E, and F. Now these two triangles ABC, DEF, to be similar, angle A, let's write it down here, angle A should be equal to angle D, angle B should be equal to angle E, angle C should be equal to angle F. This is the first rule, first condition to be satisfied. And the second one is the sides should be in the proportional. That means the ratio of the corresponding sides should be same. That means let us see this, AC by AC by DF should be equal to AB by DE should be equal to BC by EF. Let us see what is that ratio. AC by DF, 8 by 4 equal to 2. So I can say AC by DF equal to 2. You can check that 8 by 4 equal to 2. Similarly, AB by DE 6 by 3 equal to 2. BC by EF, that is 8 by 4 equal to 2 again. Then if these two are satisfied, then we will say that these two triangles are similar. Now can you tell me what are generally we can see the triangles which are similar? Equilateral triangles. Yes, all equilateral triangles are similar because they have the corresponding angles always equal. They are 60 degrees. We know that equilateral triangles, all the angles are 60 degrees. And also we know that equilateral triangle, all the sides are same. So you can enlarge them or you can shrink them so that you can make similar triangles. And also remember, similar triangles can be made congruent by scaling up or scaling down. That means by enlarging or shrinking them. Now, so you will see that the similar triangle may not be exactly like this only. It can be rotated, or it can be flipped, or it can be made as a reflection at a particular point or a axis. But we should be able to understand that two triangles to be similar, their corresponding angles should be same, and the sides ratio should be the same, or the sides should be proportional. Now, to understand the similarity, now let us look at the theorem which is also called as basic proportionality theorem or Tails theorem. The Tails theorem says that suppose there is a triangle A, B, C and a line is drawn parallel to AB, then it will divide the remaining two sides, that means AC comma BC in the same ratio. What exactly is meaning of that is, let us say that this total length is equal to 6. Let us say this total length is equal to 8. Now I have divided this into 4 parts. So this is 1.5, this is 1.5, this is 1.5 again, and 1.5 again. Now suppose, say this total length equal to 8. Now if I drawn a parallel line starting from 3 here, and what is the ratio of this 3 by 3? That means the ratio is here 3 by 3 equal to 1. That means this also should be divided in the same way. That means this should be 4 and this should be 4. This is called as basic proportionality theorem or Tails theorem. Let me repeat that. If you take a triangle and you draw a line parallel to one side of the triangle, then that line divides the other two sides in the same ratio. That means if this is taken as, if suppose this is taken as E and this is taken as F, then the basic proportionality theorem says that CE by EA, I'll write it down here, CE by EA is equal to CF by FB. CE by EA is equal to CF by FB. Now you can reverse it and you add 1 and you can reverse it back. You can say that CE by CA is equal to CF divided by CB. This is nothing but similar triangles. You can see here CE by CA, CF by CB. That means this triangle and this big triangle, nothing but CEF and CAB are similar triangles because these sides are parallel. That means these angles are same. You know that with the help of parallel lines, the angles are same and the sides are in ratio, same ratio. So these are similar triangles. Now let's take a simple example where similar triangles will be used in real life. Now suppose there is a lighthouse. You want to find out the height of the lighthouse. You don't need, generally it is used in one branch is called as indirect measurements, where you are not directly measuring it. Now suppose I have a tool or say instrument which can measure the angle, or with the help of which I can measure the angle. So what I will do, I will take this and I'll try to make the angle with the tip of the lighthouse, and I'll put a marker in between. I'll put a marker, so I can calculate this distance. Let us say that this distance is equal to 10 feet and this benchmark is 5 feet, and we know that this total distance is, let us say this part is 40 feet, so that the total is 50 feet, Now how much is this? Now I can apply similar triangles because I know that in similar triangles the sides should be in the same proportion. So I will say 10 divided by 5, 10 divided by 5 should be equal to 50 divided by x. That gives me 10 5 times, so x equal to 25 feet. So that's how you can find out the inaccessible objects measurement. In the next video, we will see in similarity of triangles different similarity criteria like we have in congruence, SSS similarity, AAA similarity, and also SAS similarity. We will also take the help of the basic proportionality theorem or the Tails theorem to have proofs on them. After that we will do some more examples on similarity. But to summarize, two triangles are said to be similar if the corresponding angles are same and the sides are in same ratio, or if the sides are proportional. Proportional is nothing but having the same ratio. Equality of ratios is called as proportionality. So that's about now for now. See you in the next video where we will go ahead with the similarity. And remember, all congruent triangles are similar, but similar triangles are not congruent, but they can be made congruent by scaling up or scaling down. See you in the next video. Thanks for visiting. Bye for now.